Alright, dear children, now let me just again continue with this expression that you learned in the last YouTube video. Now we had done up to the total force exerted by on the wall A by n molecules along x-axis. Means we are trying to measure the pressure of an ideal gas. So once you know the pressure, once you know the force, we can now measure the what? Pressure. So I write down the pressure, okay, on the wall, pressure on the wall, and which wall? A, exerted by, okay, exerted by how many molecules? N molecules. N molecules, and this is along x-axis. See, we are doing only with x-axis. Along x-axis is given by pressure means what? Force by what? Area. Force by what? Area. Now I can write this way also. This force I write on Fx. Force along x-axis. So I write on force Fx along x-axis by the area. Now area of the cube. Okay, the area of the cube is basically what? Side cube, which is a side square, which is L square. So area of the cube, okay, cubical vessel is given by L square. So the pressure means force along x-axis by the area of the what? Cubical vessel, and that area will be L square. Okay, so force is how much? M by L with Bx square, B1 square plus Bx2 square dot dot dot, it will be Bxn square whole divided by what? L square. Now this L and L square will multiply because it will be reciprocal. So we write down now this as M by L cube B1x square plus Bx2 square dot 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 up to Bxn square. But children, we actually measuring this pressure exerted by n number of molecules. N number of molecules. So what we do? We multiply by n. So we multiply what? N. So in this expression we multiply by n. This is for n number of molecules. Okay. So it will be mn. M into n is mn by L cube. Okay. With how much? This is bx square plus bx2 square plus dot 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 up to bxn square. But children, in this expression which I multiply by n, so I'll even divide by what? N also. Okay, I'll divide by what? N also. Okay, I'll divide by what? N. So because this n which I'm dividing by n is to be divided in such a way so that we take the average pressure exerted by all the n molecules of the gas. So which pressure which we are calculating in terms of this force and area is the average pressure exerted by all n molecules of the gas along x-axis. That's why if I multiply by n, I'll divide by what? N. Okay. Now this L cube means actually the volume. L cube is equals to volume, and the volume of the cubical vessel, let me mark by letter B. So your pressure equals to Mn by what? B. Okay. With bracket B1 bx1 square plus bx2 square dot 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 bxn square by n. Okay. Now this bx1 square bx2 square dot 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 bxn square by n is actually the average velocity, the average value of square of this velocity for all the n molecules. So simply just take a note outer where b1x square plus bx1 square bx2 square dot dot dot, okay, bxn square by n is the what? This is actually the average. This is the average value of bx square of velocity along x-axis, and this is for all n molecules. All n molecules of gas. Molecules of n what gas? Ideal gas. Okay. And this value can be even written by the relation, and this is given by b1 bx square with average. This sign is called mean or average. Average of square of this velocity along which axis? X-axis. That means this component, you can see this component is nothing but mean square velocity. We also call as mean square velocity along x-axis, which is given by bn square plus bx2 square dot 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 up to bxn whole square divided by what? N. So now this quantity in the expression of pressure I replace by b mean square velocity. Okay children, this quantity of pressure, expression of pressure, I'll give this as equation number 2. Now in this equation number 2, I replace this quantity by C, mean square velocity along x-axis. So from equation 2, we can write pressure P equals to what? Mn by B with Bx mean square velocity along x-axis. P equals to Mn mean square velocity along x-axis divided by what? B. But children, you know that for any molecules which are identical with respect, b square is given by what? Bx square plus by square plus bz square. Okay, now this equation is applicable for any molecules which is moving in a vessel. Because this equation is true for every molecules, this is also true for mean value of all the molecules. Mean value of what? All the molecules. So that means I write down this as mean square velocity of that molecules equals to bx square plus by square plus bz square. So changing from b square to mean square velocity. So this equation, as I said, is true for every molecules. Then this equation, the same equation is even true for mean value of that molecules also. Mean value of that molecules. So that's why I wrote mean square velocity of the molecules is equals to bx square plus by square plus bz square. Now I consider this equation as equation number 3. Okay, I'll give this as equation number what? 3. Now the next part that is very important under this case is, since the direction of motion of the molecules are all random in a what? Gas. Random in a gas when placed in a what? Vessel. That means all directions are equally possible. The molecules motion can take place in all directions. That means all directions of the molecules are equally what? Possible. That's why we can even write this as mean square velocity along x-axis is also equals to mean square velocity along y-axis and also equals to mean square velocity along what? Z-axis. That means mean square velocity along x-axis equals to mean square velocity along y-axis and mean square velocity along z-axis. That means these are always equals to each other. And this is true when the motion of the molecules are random and all the directions are equally possible. Okay, so with this is the consideration, then I write down from equation 3. Now from equation 3, what I write down? I write down mean value of square velocity of the molecules is given by, okay, so it can be given by the relation, but let me just complete this part. I miss out this part. For one molecules, this is mean square velocity, this is also mean. This is also the mean component of velocity along x, y and z axis. B to B mean velocity, Bx to mean velocity along x axis, By to mean velocity of y axis, Bz to mean velocity of z axis. So please do add this part, mean part. This sign is called mean, also called bar. So B mean square velocity of the molecules is equals to, I write down Bx mean square velocity along x-axis plus, but this equals to this. So I write down this as mean square velocity along what? X-axis only. Plus even this equals to this. So I write down mean square velocity along x-axis only. So I replace this two quantity even by mean square velocity along x-axis. So this will be added up. So it will be 3 mean square velocity along what axis? X-axis. So just see children, the mean square velocity of the molecules is equal by 3 times the mean square velocity of the molecules along which axis? X-axis. Okay, so which means I write down from here, mean square velocity along x-axis equals to 1/3 the mean square velocity of the molecules. So B mean square velocity along x-axis equals to 1/3 the mean square velocity of the molecules. Okay, now this value now I substitute in equation. one of the equation, and that equation number, the equation of the pressure. So actually this is one, should be the one equation. Well, let me write this equation only, and that means this value of B, mean square velocity, I substitute out here. That means P equals to mn by B into, now this I replace by 1/3 of mean square velocity of the molecules. Okay, now we are almost in the expression part of this pressure. Now I write down this expression as 1/3 mn by B with mean square velocity of the molecules. Okay, so that means P equals to 1/3 mn by B with mean square velocity of the molecules, okay, is the expression of pressure of what gas? Ideal gas. So this is the expression of pressure of the gas. But remember this part, children, this quantity is called mean square velocity of the molecules. This is called mean square velocity of the molecules. Okay, of the what? Molecules. Okay, now in the expression, if you see mn, okay, is the whole mass of the gas. This is the mass of n molecules of the gas. So out here mn I replace even by m is the mass of the gas, is the mass of the gas, the whole mass of the gas, okay, and B is the volume. So mass of the gas divided by volume is the density, which means I write down rho equals to mn by B is the density of the gas. Density of a gas. So children, let's add this point. Mn by B is actually the density, mass by velocity. Mass of all the gas divided by all the molecules of gas divided by volume means mass by volume is density, and density is marked by letter B, rho, sorry. So pressure can even written as 1/3 rho mean B square velocity of the molecules. So you can see there are two different expressions of pressure. P equals to 1/3 of mn B by mean square velocity, and P equals to 1/3 of rho mean square velocity. So this is the expression of pressure of what gas? Ideal gas. So we do this much today, and we do continue in the next class with the other topic from this chapter.